Hello, everybody, and welcome to our today's virtual classroom seminar, episode 13, about data pump. As the title indicates, this won't be an ordinary data pump seminar. We call it Data Pump Extreme Deep Dive with Development. And besides talking about best practices and sharing tips and tricks, we would also like to take you on a 2-hour journey to the data pump internals. How does data pump store meta information? How does it access meta information from the database you are exporting from? What happens if you set parallel? And what if you forgot to set it? Can you change it during runtime without redoing everything? How do you patch data pump? How do you trace it in case of something really goes wrong? All this and much more we'd like to cover today. And with me today is Roy Swanger, Vice President for Database Upgrades, Utilities, and Patching. Roy not only owns data pump in development as a development head, but he uses data pump in the field with customers very often, and he delivered numerous talks about data pump already. Myself, Mike Dietrich, the product manager for database upgrades, migrations, and patching. I, of course, use data pump as well quite often. And on my blog, mikedietrich.de.com, you will find one or the other blog post about tips and tricks and pitfalls with data pump. Then with us today is the Senior Principal Product Manager for Cloud Migrations, Daniel Overby Hansen. And when you visit Daniel's blog on dohdatabase.com, you'll quickly find out that Daniel does a lot more than just cloud migrations. Daniel is also a power user of data pump, and he has that habit of really wanting to dig deep into all the gory details. And he shares this passion with Rodrigo Jorge, our Senior Principal Product Manager for Patching. When you visit Rodrigo's blog, you'll find out that he really doesn't just want to go into details and dissecting releases, but you find also that he has a secret passion, which is called security. On his blog, you find a lot of information about security regarding not only patching, but regarding the entire database and the dictionary especially. Then the best to talk about data pump is actually the product manager for data pump, Bill Borgard. So Bill is our PM. He delivers a lot of talks already, and we are happy to have him here today talking about all the details in data pump because he knows them best. And as a special guest, we'd like to welcome Venkatesh Sangam. He's the Senior Director and leading the developer team of data pump. So he knows what data pump is doing and how the data pump plans for the future are, what the developers are currently working on. And we are really happy to have him here today as well. Now, for today, again, we have a full slide deck. And if you want to download the slides right now, feel free to go to mikedietrich.de.com/slides and then click on Webinar 2022, and you'll get access to today's slides. Of course, the slides are stored on Rodrigo's and Daniel's blogs as well. The typical next question is, will today's seminar be recorded? And yes, it will be. You will find it in our YouTube channel in a few days after the seminar has been broadcasted. And you find more of these sessions when you access mikedietrich.de.com/videos. Currently, we have 12 virtual classroom seminars available. This one will be the 13th, and they're all just technical topics covering. So no marketing done. We go really deep into details about not only upgrades, but also all the different migration techniques, how to migrate very large databases, how to fallback, going to multi-tenant, performance testing, either on-prem or in the cloud or in a hybrid environment, and much more. So all this for your knowledge, for your pleasure. Feel free to go there and watch our virtual classroom seminars. And if you intend to subscribe to our YouTube channel, feel free. The top link on mikedietrich.de.com/videos is the link to our YouTube channel. And every second day, we release also a technical video. With this, let me hand over now to Daniel, and Daniel will introduce you not only to today's topics and the agenda, but also to data pump essentials.
Thanks for the warm-up, Mike. Let me quickly introduce the agenda. Shortly, I will start on the essentials section, and after that, we will go through some best practices that we have accumulated over many years of working with Datapump. Then we will head into some advanced use cases with Datapump before we finally round up with Datapump Extreme or Datapump Secrets, where we will show you some of those hidden gems that you might not be aware of. But first, it's about Datapump Essentials. If you look in the documentation, it states that Oracle Datapump Technologies enables very high-speed movement of data and metadata from one database to another. We introduced Oracle Datapump many years ago as a replacement for the old export and import utilities. But Datapump can do so much more than just export and import. It really offers superior functionality, and you can use Datapump for some very interesting use cases. Hopefully, this webinar today can inspire you to use Datapump in a much smarter way. If you need to know more about Datapump, you can always head into the documentation. Information about Datapump is stored in the Utilities Guide. Hopefully, many of you are already on Oracle Database 19c or upgrading to 19c. It is our current long-term support release. So you should go into the Utilities Guide in 19c. In the slide deck, you can find a link to it. But if you want to investigate some of the new features, you should head into the 21c documentation, where you can find information about, for instance, the new checksum feature. Now let's talk about Datapump in detail. You can use Datapump basically in two ways. First and most common is Datapump in dump file mode, where you can export the data into a dump file, then transfer that dump file somewhere else, and import from that dump file into a new database. In addition to that, you can use Datapump in network mode. Here, you simply just start the import directly in the target database, and then import all the data over a network link. This can be very handy in some situations. If you compare the two options, Datapump in dump file mode requires access to the file system of the database hosts because we need to move the dump file around. Also, you need to have disk space to hold the Datapump dump file. But the good thing about Datapump in dump file mode is that you get the full functionality of Datapump. In contrast with Datapump in network mode, you don't need access to the file system of the database host, but you need to have SQLnet connectivity between the two databases, because we need to establish a database link so we can fetch all the data over the network link. You don't need any extra disk space in this case because Datapump in network mode will not generate a dump file. But there are a few restrictions that apply when you use Datapump in network mode. It's important to understand with Datapump that it is a server-side application. It's not client-side. Even though you can sit at your own computer and start a Datapump job, all the magic will happen on the database server itself. It also means that if you lose connection to the database host, if your computer restarts, don't worry, the Datapump job, the export or the import will still continue on the database host because it is server-side. Looking a little deeper at the architecture, the main functionality in Datapump is stored in a PL/SQL package called DBMS Datapump. You can just head into the database and investigate the API. There's really a lot of functionality stored in the DBMS Datapump package, but it's not enough. We also have the DBMS Metadata package that we use to generate the DDL for the objects that you are exporting. If you are exporting a table with an index, we need to have the definition of the table and the index so we can later on recreate those objects in another database. We use DBMS Metadata to extract that information. Also, Datapump uses the external table API and the direct path API. These are not public APIs that you can use yourself in the database, but there is other functionality in the database that uses those APIs as well. Those two APIs are used to very fast and efficiently unload and load data to and from the database. Normally, when you as a user want to use Data Pump, you are using one of the two clients, XDP and impdp, for export and imports respectively. That's the most common use of Data Pump. But in fact, you can use the Data Pump API, DBMS Data Pump, directly. You don't have to go through the clients. Using the API directly opens up for some really interesting use cases, and we will talk more about that later in this webinar today. For now, I will leave you in the capable hands of Rodrigo, who will take you further into the Data Pump architecture.
Thank you, Daniel. Now let's talk about the Data Pump architecture. So the Data Pump architecture, we have the operator who's going to call the expdp command. When this command is called, the first thing that's created is what we call the control process. The control process is like the brain of the Data Pump job execution. So this control process will first instantiate what we call control table or master table. This is the table where this job will track and keep the execution status and all the parameters provided for this job. And also we're going to see later on the next slide more information we have on that table. After this table is created, the control process uses Oracle Advanced Querying to put all the tasks that we need to execute for this Data Pump job in a line. So after this Advanced Querying is created, we have the worker process. So for our execution where we have no parallelism, we will have at least one control process and one worker process. When we have a multiple parallelism here, then we are going to have multiple worker process taking tasks from this advanced querying. So the worker process takes the first task of this queue, get the data from the database, and write this data on the dump file. The control process will also write data on the control file from this control table. So the control process needs to update the dump files with the control table that's going to be kept on the dump file as well. Now let's see what we have inside this control table or master table. So this table is the table that usually we see inside the database as sys schema export 01 or 02 or 3. So these tables, again, are the tables that contain a specific Data Pump job execution. It has all the job info and parameters. It has the current status of that execution. You have also the object information, the index, and this is what enables the Data Pump job resumability, because this table, if you have an abort of your Data Pump process, this table will be kept there, and then the Data Pump job can resume checking on that table the steps that were already executed. So this control table is dropped only in the end of the completion of the job if the job was successful. If it has any failure, then the table is kept there for resumability. And again, that's sometimes when we see a schema in a database, we see a lot of those tables with 01, 02, 03 in the end. That's because of the previous executions of Data Pump export that failed by some reason. You can officially force to keep the table then even when the job ends with a successful execution if you use this parameter keep master equal to yes. This table can be created like any other table. So you can create your own queries. You can have your automations to check the execution status, the execution percentage, just creating this table. And this table is the first object imported when you run impdp. So when you run impdp, first the dump job will create this table on the tar database. Then it's gonna read this table to import the objects from the dump file. So again, how we keep that table, we use this keep master equal to yes parameter. And here we see that we have in red here, the sys schema export, sys export schema 01 table being created in the beginning, and in the end, we have the table was successfully loaded or unloaded, meaning the table is going to be kept in the end of execution. We can also query this table, again, as I said, as any normal table in the database. And here we see some job information like the log file directory, the log file name, the client command that was executed, if you specified in compression, or if you restricted your job for a specific schema, you have all the information on that table. Okay, now let's talk about data pump unloading and loading methods. So we have 5 ways that data pump can use to put the data in the dump files or load the data from the dump files to your database. The first way is using data files. This is mainly used for transportable table spaces. So in that method, what we are gonna have in the dump files is only metadata, because all the data that is being loaded and unloaded is on the data files itself. So the data files are simply moved as is from the source system to the target system. If you have different NDNS, you can use DBMS file transfer or RMAN to convert the NDNS of those data files. So this is a very fast method and very useful when you're moving a full table space or a full database from one source system to a target system. Direct path is one of the fastest methods that we have. And basically because here, direct path method, we use the direct path API and will completely bypass the SQL layer. So with the direct path API, the block is gonna be created and written straight to the data file, meaning you don't go through the SQL layer and not even to the buffer cache. So that's why it's very fast, because you generate the block and you write the block straight away. You don't go through the SQL layer. But to bypass the SQL layer, you have a lot of requirements to use this method. Meaning that if you have triggers, for example, in your target table, this method won't be able to be used because triggers need to be processed and the SQL statement needs to execute to get the trigger actions. Also, for example, if you have constraints, the foreign key constraints in your table, you need to go to the SQL layer because we need to check for parent and child relationships. We cannot go straight and write a block on the data file. First, we need to check for these constraints enforcements. The next method is external tables. So this method, what data pump job will do is basically creating an external table pointing to the dump file. And then it's gonna insert as select from that external table using the SQL layer. So it's not so fast as direct path because it needs to create an external table and go through the SQL layer. However, this is still very fast, especially if you have huge unpartitioned tables, because you can take the advantage of the SQL parallelism to load all that table in your target system in a parallelism way. Also, insert as select. This is the method used when you have network links. The reason you will only have the insert as select for network links is because with network link method in impdp, you don't have a dump file. So you cannot use direct path, neither external tables. So this method is only valid for network links when you have a DB link created from the target system pointing to the source system. And finally, conventional path. What is conventional path? Is like others. When none of the previous method applies for a given table, then we go using the conventional pathway, which is insert statement by in statement. This is much slower than the others and used only as a last resort. However, we have some objects, some very odd scenarios in Oracle database, for example, with blockchain tables, where we need to first insert a line to create a hash for that given line before inserting the next line. So that's why this method exists, to cover these odd scenarios in Oracle database. How do we select an unloading or loading method? Using this access method parameter. One very important thing to mention is that if you unload the data from your database to a dump file using one of those ways, you can load using another way. You're not restricted to the same way you unloaded to load the data on the target system. That's because the way the data pump job writes in the dump file is in a generic way that any method is allowed. We recommend you to not specify any method. If you don't do so, Oracle will use the current stats for that table to determine the fastest way to use for that given table. So here, when we use this matrix parameter, for example, we can see using the expdp which method was used by each table. So we have here in line using direct path, for example. This is the method used for those two tables. Maybe there are some other tables, like I said, unpartitioned, huge tables that Oracle probably will choose that sunrow table method. So you will see here in red. Now with Roy, that will talk about data pump metadata.
Thanks, Rodrigo. I am going to talk about the basics of metadata because even though data pump starts with the word data, metadata is equally important in your export and import operations. So the first question is, what do we mean by metadata? Well, an Oracle database isn't just a store of data files. It includes information about all those different objects in your system, which define the semantics and operation of the database. I'm talking about things like the table definitions and how they're structured and the objects that relate to tables like triggers and constraints and statistics and so on, but also other non-table objects such as your PL SQL packages, your users, your grants, roles, privileges, even audit policies have information stored in the data dictionary that tells us how they work and how to move them in and out of a database. The relationship between metadata can be a hierarchical one, like you see here with tables, for example. A table might have an index attached to it. It might have constraints or triggers or statistics associated with it. And all of those are kind of defined under a tree of information in what we call an object path. So that's how we define the access to each kind of metadata. If you're wondering about what all these object paths are, we actually have some system views that you can access to get a full list of every kind of metadata that you can access using the Metadata API. Now, that list of information will vary based on whether you're doing a full database export or import, a schema job, or just working on a few tables. Because, for example, audit policies only exist at the full database level, not at the table level. So we can query those views and you can get a list of the literally hundreds of object paths that are available for each kind of export or import. And that can be important when you want to include or exclude specific objects from your job. And we'll get more into how to use include and exclude later when we talk about best practices and some advanced techniques. But know that that's why you need to know those object paths so that you can be very precise, or maybe less precise if you want, about including and excluding metadata objects. So up to 21C, include and exclude for data pump were mutually exclusive. That means you can either exclude certain types of objects, which means that the data pump job will export or import everything except for those objects that you excluded, or you could include objects, which means that the data pump job would work only on those objects that you included. Well, starting with 21C, you can now combine include and exclude in the same job. And the way that will work is that we first process the include. So you gather the list of different object types that you're going to want to work on, whether it's tables, indexes, constraints, and whatever. And then from that, you could exclude certain types, like you could include tables, but then exclude any tables that start with a particular string in their name. So it becomes even more powerful starting with 21C. Now, some metadata does have dependencies, and there might be relationships that aren't obvious to you. So I'll just touch on a little bit of that here. When we talk about dependencies, what we mean is that for something like a table, if you exclude the table, you will also exclude any objects that relate to that table, your indexes, triggers, constraints, grants on that table, and so on. And there are other ways that this comes into play as well. For example, if you exclude an index, you'll exclude the index statistics for that index, not necessarily the table statistics for the table itself, though. And one other thing I just want to mention is that some types of metadata are maybe different than you might expect. For example, primary keys in the Oracle database are implemented as unique indexes. However, they're treated as table objects, as a constraint on the table, not as an index themselves. So that's just a very high level on metadata. Now I'm going to hand you off to Bill for a little bit more.
Thanks, Roy. Let's continue with more data pump requirements. First, by default, any user can export their own schema. A user with the roles export full database and import full database roles can also export the full database as well as somebody else's schema. It's important not to use as sysdba when you run your data pump job. It has some restrictions on the use of parallel DML, and in addition, it had in some situation as sysdba can circumvent some internal consistency checks that are important. If you want to export scheduler jobs that are stored in sys schema, you can look at the method in the Oracle support note, how to exclude scheduler job from data pump export. Now, while it describes a way to exclude them, you can also use the opposite approach and include them in a full database export. And finally, in addition to setting roles to export a full database, you must also set the table space quota to unlimited to allow for sufficient space for a control table that is created and written to by the control process as well as all the workers. Next, you need a directory to store the log file and optional trace files, even if you do a network mode import. Remember that data pump runs server side, so the directory should exist on the database host. Now you can find more details about this in the Oracle support note, export import data pump parameter directory, how to specify a directory. Another use case for the directory is for storing SQL file. Now this is a file that's generated if you use the SQL file option on import to record the DDL created by data pump for the import job. Also, data pump uses advanced queuing to communicate between processes, and advanced queuing needs a streams pool. Size in the range of 64 meg to 256 meg is usually reasonable for this purpose. You also need to decide on a processing mode for your export or import. The default and recommended value is schema. It allows you to choose the schemas of interest, and when migrating to an autonomous database target, this is also the method that is required. Now, full can be used for migrating all data, but despite the name, there are some schemas that are never exported, even in a full export or import, and sys is an example of that. When you run the export or import client, there are a couple of ways to specify parameters for the job. Now you can always specify them on the command line, but we recommend using a parameter file. The example on the slide uses a par file parameter to specify export.par. This contains all the parameters for that particular export job. Now, why use a parameter file? Well, first of all, it avoids errors that can come from typing long, complex data pump commands, especially when your target is a cloud target and you need to specify a credential and a URI to the object store. So it's better to put that information into a par file. Also, getting escape characters correct can be challenging, especially when you must escape an escape character. So And I guess a final reason would be, imagine using transportable table spaces where you have to specify multiple data files. It's just easy to put all those data files in a par file and not having to type them on the command line. And last but not least, it's important to have a consistent export. By default, exports are only consistent on a per table basis. In this example here, you can see that each table is exported at a different system change number, or SCN. The SCN marks a consistent point in time in the database. So it is possible to export all the tables with the same SCN. As an example here, all tables are being exported with the same SCN of 100. Now to do this, you need to use the data pump parameter flashback SCN or flashback time to specify the SCN. And that'll give you a consistent SCN across all of the tables that you're exporting. And that SCN is used by export to enable the flashback core utility. The best practice is to either use flashback time, which gets translated to the SCN nearest to that timestamp, or to use a specific SCN that you prefer. Now, in both cases, this allows all the data in the exported tables to be retrieved as of a particular SCN. And here are the syntaxes for these mutually exclusive parameters, and you can even use the legacy original export utility parameter consistent equals y, and that maps to the flashback time parameter in data pump. Now, as you may have guessed, this requires that your database be configured for automatic undo management. Now, another approach that can be used to export is to export from DataGuard. You can turn a DataGuard into a snapshot standby temporarily to do the export. You can't export from a regular DataGuard or an active DataGuard because data pump must be able to create the control file. And even in 19C, DML redirect won't work because create table for the control table is a DDL command, not a DML. And by the way, it also helps to export during off hours. So now on to Daniel for a demo.
Thanks, Bill. Now let's take all those pieces and put them together. I've prepared a little demo where we can do a simple export and import. First, there are some preparations that we have to do to the database. I'll set the environment so I can connect to the database as sysdba. I'm creating a user called DP user that I'll use to run data pump. I grant the two roles that allow me to do full export and import of the database. And I need quota on a table space so I can create the control table. Also, I need a directory in the file system where data pump can store dump files and log files. I refer to that directory using a directory object in the database, and I grant read and write on that directory object to my data pump user. I bump up the streams pool a little so it's ready for starting data pump jobs. This is my export parameter file. I'm exporting the schema app to the directory dpdir, and I've made it a consistent export. I can start data pump exports by using the client expdp. I connect as my data pump user, DP user, and I refer to the parameter file that we just saw. Now the data pump job is started. The metadata is being extracted into the dump file, and pretty soon as well, the actual data will go into the dump file as well. The Eventually, I'm notified that the job successfully completed. So let's look into the directory where we stored the dump file and the log file. You can see that there is now a dump file and a log file as well, which contains the same information that was spooled to the console. So now let's try to import from that dump file. First, we need to drop the schema so we can import it again. This is my import parameter file, and I'm importing the schema app from the directory dp-dir. Since it's an import, I use the impdp client to start the data pump job. I again connect as the dp user, and I refer to the parameter file. It should be fairly quickly to import this small schema. And in the end, I'm notified that the job successfully completed. All is good. So this is how you can very simply export and import data using Data Pump, but there is so much more to Data Pump. So let's head into the details and explore more cool options of Data Pump.
Thanks, Daniel. Data Pump is a very powerful, very flexible utility, and we'd like to give you some best practice for how to get the most out of that power and flexibility. When it comes to performance, it pays to recognize that Data Pump is a very heavy user of your data dictionary. We're querying those dictionary views and tables and fixed tables to get information about the objects in the database and where the data is stored in the best way to export or import it. So it really helps Data Pump performance to have current, accurate statistics on your sys and system schemas. If you can gather those schema stats in advance, you will find that Data Pump runs much better than if you have stale stats on this or that dictionary table. And if you don't want to gather schema stats on sys and system, you can do kind of a lighter weight version of that by gathering dictionary stats. That will also help. The other topic related to statistics in Data Pump is that we generally recommend that you exclude statistics from your Data Pump exports, and that way you don't have to take the time to export stats and then import them in the target system. The reasons that we recommend that are twofold. One is that exporting stats can be a pretty time-consuming operation. By the time the statistics are extracted from the database, packaged up, and then imported into the target system, you could have easily gathered those statistics on the newer, faster hardware to which you're migrating anyway. But the second reason is also important, and that's that as part of your export and import, you're very likely going to be changing the way that data is laid out in your data files, whether it's changing the amount of free space that's available in your data files to implementing new types of compression or encryption, or indeed even changing the partitioning layout of your database. The statistics could be very different in your import side target database. So gathering the stats afterwards is generally a good idea. Of course, if you don't have time to gather the stats afterwards and you want to bring the stats with you as part of the export and import operation, that's fine, but you're still going to want to regather those stats later. I should mention, by the way, that after you import into that target database, you should go back to those dictionary stats and regather those on the import side. The reason for that is that the process of importing will have inserted lots of rows into those dictionary tables, like obj dollar, tab dollar, user dollar, source dollar, and updating the statistics there will just be beneficial for your entire database. Another thing that we recommend for every export and import operation is to include diagnostics in your log file. Now, we'll talk more about different types of diagnostics that you can apply to Data Pump jobs later. But for the log file in particular, these two parameters, metrics, which was added in 11.2, and log time, which we added in 12.1, can give you a very robust set of information to help you understand the performance of your Data Pump export or import. And let me show you what I mean by that. If you don't specify those parameters, the default would give you a log file like you see at the top, where you get a sense of what is being, in this case, imported. And you see for each table, for example, that we've imported the table and how many rows it had. But look at the wealth of information you get by specifying log time equal all, which gives you that timestamp on the left side there down to the microsecond, and metrics equals y that tells you for each individual table or object, not only how long did it take, but what method was used to move it. And we'll talk about those access methods later and see why that's important as well. Now, we didn't make this the default yet for Data Pump because it does introduce inherent variability into your log files, and we didn't want to break customers' existing tooling and scripting and have to have them filter out timestamps, for example, to see whether a job had the same results as the previous run. But at some point, we may want to make these the default, so keep an eye on these and use these parameters whenever you're performing an export and import. Parallelism is another area that you can look at for performance of your Data Pump jobs, and indeed, it's just about the only user-accessible knob that you can use to change the performance of a Data Pump job. Parallelism that we recommend is up to 2 times the number of physical CPU cores on your system. Now, you might want to balance that with other workloads that are on your system if you don't want Data Pump to consume all of the system resources, because Data Pump was designed to use all the resources that you're willing to throw at it. So if you have other workloads on the system, you might constrain your Data Pump job and say, well, we have 32 CPUs, but we're going to do an export with parallel 4. But if all you're doing is migrating a large database and you've got 128 physical cores on the system, then yes, you could do an export with parallel 256. We have customers who do that, and it's very efficient. But let's get back to this concept of physical CPU cores, because it's not the same as CPU count. That parameter that you can query out of Oracle, CPU_count, is actually the number of physical cores times the hyperthreading factor for that CPU architecture. So on an x86 system, which is generally two-way hyperthreaded, CPU count will be 2 times the number of physical CPU cores. But on other CPUs like PowerPC, like Spark, you may find as many as 8-way hyperthreading. So you can't depend on CPU count in those cases. You actually have to know how many physical cores there are on the system, because generally system I/O is balanced to physical cores, not to hyperthreading. And then as a side note, in Oracle Cloud terms, an OCPU is 1 hyperthread of an x86 core for the x86 architecture. So for, say, a 4 OCPU shape, you should be comfortable going to parallel 4 with Data Pump. Now, when it comes to parallelism for exports versus imports, it's important to note that multiple log files are absolutely necessary if you're going to use parallel on the export. So if you're going to export with any degree of parallelism greater than 1, then use the wildcard that would enable us to create multiple log files, because that way each individual parallel process that's writing data to a file gets its own file to write to, and they won't be blocking each other for file access. On import, however, the degree of parallelism used to export a database has nothing to do with the degree of parallelism you can use to import effectively. You could have a massive database that was exported with just one huge data file, and then you could go parallel 32 on the import and have 32 workers all loading in parallel out of that single file, because readers do not block readers to on-disk files. So it doesn't matter what you exported with, you can import with whatever would be most efficient on your target system. The last thing I want to talk about in terms of best practice is lobs. Now, we've been recommending since 11.1 that customers move away from the old basic file lobs to secure file lobs. And there's no better time to do that than when you're performing a Data Pump migration. Now, the reason we've recommended moving away from basic file lobs is summed up especially at the bottom of this slide. Basic file lobs do not allow parallel DML, inserts, updates, and deletes, into or out of a table with a lob column. And that's true even if that table is partitioned. So why does this matter with Data Pump? Well, if you have an export that's running really slow and you go to support and say, why is my export running really slow? The first thing they're going to ask you is, are there tables with lob columns involved? Because what's going to happen in those cases is that no matter how much partitioning you apply, no matter how much Data Pump parallelism you specify, we can use one and only one process to unload a table with a basic file lob column. If it's secure files, then we can use a parallel query, we can take advantage of partitioning, and it's much more efficient for us. So we recommend, if you have basic file lobs, well, I'm sorry, but there's nothing we can do to improve performance of the export. But on import, you should be transforming to secure file lobs, because Data Pump has this parameter, the transform lob_storage to secure file, that will transparently change your basic file lobs to secure file lobs. And it's application transparent as well. So you don't have to worry about breaking applications by doing this. The only thing you'll see is that the lob operations for those applications will be on the order of 5 times faster. Let me give you some data to back up these claims. We've done some testing, obviously, for performance here. And here you see what happens if we export the same 32 gig table when it had basic file lobs, or import the same 32 gig table with basic file lobs and then with secure file lobs. And what you see in the first case is that we have to use direct path because it's faster on a single process load than external tables. So we use direct path to go as fast as possible. And still it takes almost 4 times as long as using external tables with parallelism with secure files. So not only will secure files make your imports faster, but they're going to make your database faster after the import. So again, no better time to convert from basic file lobs to secure file lobs than when you're already migrating with Data Pump anyway. So those are a few tips on performance that should help get you going. Now I'm going to hand you off to Mike for some more best practice.
Thanks, Roy. And I have some best practices in addition for you. And the first one here, and I think this is one of the most important things to remember, is that when you define dump file, not just make it one single file name, always use the %L. In the older days, it was %U, but %L allows 3 digits or up to 1000 dump files. You will see later on when we talk about all the parallel ingredients and details, how important that is. So this is a must. You must set this %L in your dump file parameter variable to allow the creation of multiple dump files. Optionally, you may add a file size parameter if you want a certain given maximum size for your dump file. That could be also useful. For instance, if you want to upload something to the object storage and there's a limitation on how big the files can be. Then use compression if you have the advanced compression option. That's the small caveat here. You can decrease the size of a dump file significantly. You can speed up your export dramatically in some cases for certain types. But as soon as you say compression equals all, then in DBA feature usage statistics, the counter will tick up and your database will be marked to have used the advanced compression option. In addition, you can define also compression algorithm since a few releases. And here in my example, we use medium, and I show you in a second which of the algorithms you have as a choice and which ones are the ones we most likely recommend. Basic is the algorithm just having the old way how to compress dump files as we introduced it in 10 when Data Pump came up. This is not the best algorithm in terms of performance, also in terms of CPU load, and also in terms of the size of the dump file. Our recommended option usually is medium, because medium balances best between performance, how quickly do you export, and how much load do you put at the same time on the CPUs, and the size of the dump file. Low is something you would use only if you would like to have a little bit compression. It comes very close to the old basic algorithm, but with very, very little CPU load, while high gets you the best results in how small is my dump file. In exchange, unfortunately, it also demands a bit more CPU resources. This is why medium usually is the best way to go. And here we have some numbers. So a real life example, this was a 12.2 EBS database export. And the file size when you did nothing was 5.5 gigabytes. That's okay. With all basic, so all means metadata, which is the default anyways, and basic algorithm, compression algorithm, we brought it down to like 90% smaller dump file. With all low, a little bit bigger, not smaller, and all medium then balanced actually best in terms of how long did it take? 4 minutes, 55 seconds. What was the ratio and the size of the dump file? So it balances in most cases the best. Another example here below that, where you see also that the low algorithm really doesn't give you good performance, and high really may take much longer, but it gives you the smallest dump file. The default compression type for metadata, interestingly enough, compression metadata only is on by default. And no worries, this doesn't let the counter go up for advanced compression option. It has no extra requirement, but we realized that due to the fact data pump exports metadata in XML files, that can really take a little bit of compression. It helps a lot in terms of the size of the metadata. And one thing which is really important, and this is why we put it as a pro tip here on the slide, when you have a compressed dump file and you want to import it, that does not require the advanced compression option. Only the export requires the advanced compression option, and not for metadata only, but for data or all. Yeah, now you have a big dump file and you transfer it somewhere, and it happens from time to time that this transfer goes wrong. There will be a corruption, or even worse, there's tampering happening. How can we protect ourselves here? How can we protect a dump file? And with 21C, we have a very good option to do that. First of all, you can, during export, generate a checksum. And the difference between generating a checksum by yourself instead of letting data pump do it, when data pump does it, first of all, you have a variety of choices for the algorithm, much, much better than the MD5. So as a SHA-384 is much, much better. But in addition, that checksum will be encrypted and stored in the dump file. So it's very hard to really go around that and tamper it. When you receive that file and you want to import it, the first check could be just a verify only, which now checks if the checksum is correct, still correct. And when you then do the final import, you may not want to have this checksum check running again, so you can skip it with verify checksum yes. Of course, this is just available from 21C on, so currently until 19C, you still have to deal with MD5 checksum, for instance. And for instance, when we upload something into the object storage there, we can verify this with DBMS Cloud and check whether the checksums are still correct. Finally, in the best practice section, most useful, especially in the cloud environments, to avoid any noisy neighbor disturbance, and especially also if resources are insufficient, restrict the number of data pump jobs in a multi-tenant environment. I said cloud because we saw this coming up in cloud environments quite quickly with a lot of PDBs. And unfortunately, these max data pump jobs per PDB and max data pump parallel per job, those parameters are set so generously high that you easily can create a lot of noise. So it may be really useful to restrict both of them, especially in a multi-tenant environment, but really, really quite often in a shared cloud environment where we use multi-tenant. So keep that with you. If you search for the parameters, I think you may find also some useful Moz notes. And with that information, we would like to conclude the best practices. And then Bill will take over and start with the second part of today's talk. Now we go more for the internals. Over to you, Bill.
Hey, thanks, Mike. Let's dive into the parallel feature of Data Pump. Now, if you use the Data Pump default for parallelism, parallel equals 1, a job starts with a minimum of 2 processes, a control process and 1 worker. The control process verifies the parameters in the job description. It controls and assigns work items to the worker. However, Data Pump can export and import metadata and data in parallel. So you can optionally specify a degree of parallelism for the Data Pump job. In the example here, we're using parallel equals 4. Now that degree of parallelism of 4 is the maximum number of active parallel processes, including active workers and parallel query processes that can be concurrently executing. It does not include the control process nor the shadow process. Any workers that are not engaged are sitting idle waiting for work, and Data Pump will only start the number of processes that it really needs to complete the task. Now, if you're going to use parallelism, then you also need to specify multiple dump files for the parallel throughput. Now, the easiest way to do that, to specify a dump file set, is to use the %L wildcard character in the dump file name. Now, having multiple dump files avoids file locks, since a worker will lock the dump file exclusively when it writes to it. And using parallel or degree of parallelism along with the wildcard in dump file is necessary to have parallel throughput. You can also use parallelism on import. Locking isn't an issue here because the workers are only reading the dump files, and the degree of parallelism value for export and import are completely separate. For instance, if the target system has more resources available than the source, you can set a higher degree of parallelism for your import job than was actually used on the export job. By the way, you can even set or change the degree of parallelism after the job has started. Later in the webinar, we'll show you how to do that, how to change the parallelism for a running job using the interactive commands. Last topic I'd like to cover is introducing the Data Pump worker. What does it do and how is work assigned to it? So what does a worker process do during export? Well, the worker process may export metadata using the DBMS metadata API to collect object metadata for export. And on import, it would convert the metadata to DDL and PL SQL for import. The worker writes the metadata it collects to a dump file, or in the case of network mode, it converts that metadata for execution. The worker process may also be processing data using the data layer to unload in the case of export, or load in the case of import, or move in the case of network mode import of the data from source to target. If you're doing a network mode import, it's going to use the DBMS_metadata API to convert the source database metadata for execution and move the data to the target. And finally, export and network mode import work in multiple phases. The export begins with one or more workers collecting metadata for export. The export can unload metadata in parallel with worker processes. For metadata export, each object path is a metadata work unit. Export collects the information as it progresses, and including finding table data items to export. It determines the number of workers for the metadata export, and it holds some of the workers in reserve if data is also being exported. Now, for data export, the table data metadata items include size estimates that drive the prioritization of the table data work item units. The table data item work units are scheduled as worker processes become available. Now, if the overall export time is dominated by data export, Data Pump's going to try to initiate that data export as early in the job as possible, and with as many workers as possible. However, it may not be possible to determine a true estimate of the data export time early in the job process if large table data items are not discovered early. Export can also be dominated by metadata export, for instance, in the case of a transportable table space export, in that case, it's only exporting metadata.
Thanks, Bill. Let me delve just a little deeper into what happens when you export metadata pre-12.2 or 12.2.01 and later, because that's the dividing line where we implemented parallel metadata export and import for Data Pump. What will happen is for your 12.2.01 and later databases, 18, 19, and so on, most metadata will be exported and imported in parallel. And I say most there because there are some types of metadata that have dependencies, such as types, where you might have a type hierarchy that needs to be exported or imported in a particular order due to type evolution. But for most metadata, we will export and import it in parallel now. So what do we do before 12.2? Well, before 12.2, when we were exporting, the very first phase that you're going to see in your log file is the estimate phase. And what we will do by default is we will look at where the data is laid out in your data files, and we'll count the blocks. So we'll go query the DBA segments, views, and so on to find out what are the biggest objects that we need to export. And that way we can get the right ordering to make the export as efficient as possible. But that estimate phase can be time consuming on a large database. You could speed it up by saying estimate equals statistics, but sometimes you don't have accurate statistics, and then that can throw off the export process itself. And only once we're done the estimate phase will we then start exporting the metadata with a single thread, and then we will also export the data using parallel processes. Well, we mix that up in 12.2 to make it more efficient. With parallel metadata export, we start exporting the metadata as soon as we know what it is that we need to export from the database. So we gather the set of objects we're going to work on, and while we are estimating the data sizes, we start exporting metadata in parallel. And again, it's most of the metadata will be exported in parallel. We're talking about things like users and table definitions and constraints and roles and so on. So if you look at your log file, you can actually see this difference in how we operate right there in your log file, especially if you use the metrics equals y parameter that I advised you to use earlier under best practice. Pre-12.2, what you can see is that we start with the estimate phase, and then only once that is completed do you see the startup of our other parallel worker processes. So that means we've only got one thing happening until the estimate is done, and then we start all those parallel processes to start actually doing the real work. Whereas in 12.2 and newer databases, what you'll see is we start up all those parallel processes right away, and then as soon as they can, they get going on exporting metadata, and eventually, after the estimate phase using statistics, we will start exporting data as well. So it makes the whole process much more efficient, especially for those metadata-heavy databases like your SAP databases, your e-business suite databases, and other enterprise applications. So mentioned this earlier in terms of best practice, but it's a really good idea to have up-to-date statistics on your sys and system schema, because both the estimate phase and all of this export of metadata is going to be a heavy user of dictionary tables and fixed objects. That will make your estimate phase and your metadata export go so much faster if you have good statistics there. So now let me just give you kind of a boxes and arrows type of example of how this really plays out in terms of processes. Let's say you've got 3 subpartitions that you're going to export here, and you specify parallel equals 6 for data pump. In this particular table, as I said, 3 subpartitions. And we're using a wildcard so that you get parallel dump files, which is the right thing to do. Now, how many processes would you expect to get out of this example when you said parallel 6? Answer might surprise you, because what you'll get, first of all, is the control process. So that's 1. And then you have 1 process that is unloading the metadata in this case. And then the next worker might look at a partition and say, that is above the threshold of size where we would use intra-partition parallelism of external tables. So instead of just unloading that data myself, I will call parallel query and invoke 2 PX processes to unload that partition in parallel. And then the next subpartition might be smaller. Maybe it's below that threshold. So we have maybe 1 direct path unload of that subpartition. And then the third subpartition, again, is larger and takes advantage of 2 parallel processes. So that gives you the 6 active processes that your parallel 6 that you specified for data pump asked for. You've got 4 PX processes and 2 worker processes, 1 on metadata and 1 doing direct path unload. The other workers are coordinating things. But what you also have are 2 currently idle processes, worker processes that aren't doing anything because you specified parallel 6, and we only want 6 processes unloading data at any given time. So even though you said parallel 6, we end up with a total of 11 processes here. We have the control process, we have 6 worker processes, and then we have the 4 parallel query processes running all at the same time. Now, some of those processes are idle, but it pays to remember that this can happen because the process count on your system may throttle the number of processes that you can spawn. So that's just a little bit of a look under the covers of how parallelism works for data pump.
Now, a worker process may use the dbms_metadata API to convert metadata to DDL and to PL SQL for import. A worker process may also use the data layer to load or import the data. A network mode import uses the dbms_metadata API to convert the source database metadata for execution and move the data to the target database. Now, import assesses all import tasks by reading the control table from the dump file. It determines ordering requirements, mostly ordering the import by object path. In general, the object path is strictly followed for import. Table data cannot be imported before the table, but individual table data items can begin as individual tables are created. And parallel metadata import even works when the export wasn't done in parallel, such as if the export was done in a release before 12.2. Furthermore, the parallelism on the export and the parallelism on the import are completely disconnected, so you can have much more parallelism on the import than you could or might have had on your export. 12.2 has much more parallelism for metadata import. Everything is imported in parallel except the items with dependencies, type hierarchies, schemas, and procedural actions. There are 2 types of data pump parallelism here at work. One type is applying or allocating a worker per petition or subpetition or per small table. Over a certain threshold, for a large partition or a large unpartitioned table, a worker can be a coordinator for multiple parallel query processes. Now, a bit about the internals. Metadata is exported in XML documents from the dump files. Each XML document contains a certain number of objects of a given type. One XML document is allocated to a worker at a time. So for example, if there are 162 user objects to import, there are going to be 2 workers that each get to import 80 users per XML document. And then one worker is going to import the last 2 users, while other workers may actually remain idle. Now this works for conventional dump file imports as well as transportable table space imports since release 21C. The restart works the same as always, and the status command will show multiple workers on the metadata. Now here's an example of log files, snippets from log files, where we can see the difference using parallel equals 8 versus a pre-12.2 import that was not using as much metadata parallelism. So here you see that there's one worker performing all the work, taking about 50 seconds, versus with parallel equals 8 on the metadata, you get 8 parallel workers completing the task versus the single worker for pre-12.2. And notice the difference in the completion time. It's down from 50 seconds to about 14 seconds, about 5 times faster. And finally, looking at a performance comparison. Now this is a performance comparison for an EBS test database. The numbers are in seconds, and it shows that the 12.2 import with parallelism is considerably faster than the 11.204 import, notably for tables, for grants, for packages and views, and especially for indexes.
Thanks, Bill. So is there everything parallel? Yeah, not always. There are a few things which, unfortunately, in 19C don't get progressed parallel. So first of all, the network import does not support loading metadata in parallel. Now you may ask yourself, is that an issue? Well, if you have like 500,000 partitions and subpartitions, that may be an issue at some points. Second thing is, there's no parallelism for basic lob files. You may know that from some experiences when you exported a database with data pump and you had basic lobs, the old lobs since 8i there, and it went really, really slow. But we told you before, the relief is very simple. Convert them to secure file lobs. Use dbms redefinition or a 19C online table move that allows you to move from old basic file lobs to secure file lobs. And another thing to mention, there's no parallelism for metadata export and import with transportable table spaces. And we face the same problem, like you have database with 500,000 partitions and subpartitions, and then things can become really, really slow in the metadata phase. So when you export what is in your table spaces and when you import it again. Good thing is, this is there since 21C. Now, for most of you, that will mean with the next long-term support release 23C, but at least it's coming, it's there, and we heard you. And with that information, I hand over now to Venkatesh for faster patching.
Hello, my name is Venkatesh Sangam. I'm the Software Development Senior Director for the Database Utilities team. In this session, we're going to cover faster data pump patching using dpload, as well as data pump bundle patch. dpload is what gets used to patch data pump. Traditionally, this has been slower because it's rebuilding all of data pump as well as metadata API changes, along with ensuring that all the dependencies are handled correctly. As you can imagine, this is not the most optimal approach to rebuild everything, irrespective of whether the objects have changed or not, and dropping and recreating them. So that is why we had to invest in a new and improved dpload so that we can get faster, reliable, and cleaner approach to patching data pump. So what does this new and improved DP load do? This basically ensures that patching performance is improved by up to 90%, as well as it reduces the number of invalid objects by up to 90%, and also up to 0 in a subsequent patch. So which means that as and how you continue to use DP load, you will actually eliminate all the invalid objects in the system. This also reduces contention because the scripts that the DP load calls have been refactored and split into a much more granular set of things so that we can actually have better control on contention as well. So in effect, basically it reduces the patching time, it reduces contention, and it eliminates invalid objects up to 0 in subsequent patching, as well as in some cases when the initial patching may take up to a few minutes, whereas the subsequent patching will be close to a minute. And again, it depends on the number of objects that have changed. This slide shows the distinction between what we call as a DP load patch, as well as what a data pump bundle patch is. The DP load patch is basically the patching infrastructure change that we have done to improve the patching performance and make it more reliable. It does not require any downtime to install, and it can be installed into an Oracle home, into a running system without needing any downtime. This also is rack rolling, meaning on a rack-enabled environment, we can apply this without needing any additional downtime. On the other hand, data pump bundle patch is a set of functional fixes, and which basically improves the running of the data pump job itself. Now, it does have a lot of important fixes, and it does mean that this is not rack rolling because it has functional fixes. In some cases, it may need downtime, which means that you cannot apply while the data pump job itself is running. So as long as the data pump job is not running and it's not in use, this is non-binary online patchable. This slide shows that the data pump patch as well as the data pump bundle patch can be installed independently. The data pump bundle patch, the data pump patch itself can be installed on its own without requiring a downtime, and any subsequent data pump patch applied will make use of this new infrastructure to make it more faster and performant patching. The data pump bundle patch is tested with every RU starting 1910, and the patch numbers are listed here.
Okay, it's time for the final section of today, Data Pump Extreme. The first thing that we will cover is SQLFILE. You can extract metadata from a dump file using the parameter SQLFILE. What does it mean? Well, if you have already exported your data, your schema into a dump file, you can use data pump import to investigate that dump file and extract the definition of the metadata and put it into a file. You don't have to actually import the entire dump file in order to investigate the definition of the metadata. No, you can simply just extract the definition and put it into a SQL file. When you start data pump import and you've specified the SQL file option, data pump will not do an actual import of the data. It'll just extract the metadata and put it into a file. If you have a dump file that contains a schema-based export and you extract the metadata, it'll look something similar to that. First, data pump needs to create the user, in this case TPCC, then apply grants, and then start to process the metadata, tables, indexes, and so forth. All that will be put into a file that contains all the statements that data pump would eventually execute. How can you use the SQL file? What is the use case? Well, one of the use cases is when you need to create really big indexes. So imagine a schema that looks something similar to that. We have 10,000 small tables and one really big table. We also have 10,000 small indexes, and we have one really big index. We learned previously today that when Datapump creates indexes, it'll create many indexes at a time, and each index will be created with a parallel degree set to 1. That is very efficient if you have many small indexes, but it is also very inefficient if you have some very large indexes. So let's get the best of both worlds. We will let Datapump create the small indexes, and we ourselves can create the big indexes with a parallel degree that we find is suitable in this situation. So if you head into the source database, you could query user segments to find the indexes of interest, the big indexes. How big should they be? It depends. In this case, I found 3 indexes, big 1, big 2, and big 3. So when I import this data, I will exclude those indexes from my import. The tables that the indexes belong to will still be imported, but not the indexes. Then I can combine the include clause with the SQLFILE clause to extract just the metadata information of the 3 indexes, big 1, big 2, and big 3, and put that into a file. I can then investigate the file, extract the DDL statements that I need to create the indexes, and then create the indexes in the database with a parallel degree that I find suitable for this specific case. I've prepared a small demo where we can see this use case work. First, let's investigate the schema and perform an export. So we connect to the database as the schema app, which is the schema that contains the tables and indexes. By querying user tables and user indexes, we can see that there are 10,001 tables and the same amount of indexes. Also, by investigating user segments, we can see that there is one big table and one big index. All other objects are really small. So let's go ahead and export the schema app. I've set parallel degree set to 8, multiple dump files, and no statistics. I'm connecting to the database as DP user. That's the user that will be doing the export, and I refer to the parameter file. Now the schema app is being exported into my dump files. There we have it. So now let's try to import everything. Allow Datapump to create everything, including the big index. So I have a parameter file. It's very simple. I import everything using a parallel degree set to 8. Again, I start Datapump import impdp and refer to the parameter file. Now Datapump will start to create everything, including all the 10,001 tables, including the big one, all the indexes, including the big index. So we'll be creating the big index with parallel degree set to 1. Okay, it completed in almost 27 minutes. Now let's try to redo it, but we will exclude the big index from the Datapump import, and we can do that in our parameter file by setting exclude parameter to index and then specify the name of the big index, in this case, big 1. So we will leave out the big index, but import everything else. All the metadata, all the tables, all the indexes, and this time a little over 21 minutes, but we are still missing the big index. So we have a new parameter file where we are combining include and SQLFILE to just generate the DDL for the missing index. Let's start Datapump import to generate the SQL file. That's fairly quick. And let's have a look. Here we can find the DDL, the create index statement for the missing index. So let's grab that. Oh, you can see here parallel degree 1. That's not very good for a very big index. Grab the create index statement, connect to the database as the app user. And now let's create that big index. But notice that I've changed the parallel degree to 8. So now we can create the index much faster than Datapump would have. In this case, it takes almost 3 minutes to create that big index. So now we can reset the parallel degree on the index. And now let's do a comparison and compare the numbers. In this case, we could save almost 3 minutes by creating the big index ourselves instead of letting Datapump do it. So, is it really worth the effort? We saved 10–15%, almost 3 minutes in this case, but I also had to do some manual work. So is it really worth the effort? And as always in IT, the answer is it depends. This was a fairly small example. The index was only 5 GB in size, but imagine you have a very large database with some indexes that are 10, 50, 100 terabyte in size. There, it really makes a crucial difference if you can put a proper parallel degree on the index creation. So this could be a really good use case for using the SQLFILE option that you can find in Datapump. If you need to extract the definition of an index or any other object, instead of using the SQLFILE option in Datapump, you can also use DBMS metadata directly. That's one of the APIs that you can use as well. DBMS metadata has a function called getDDL that you can use to create the DDL statements for any object in the database. And Datapump, in fact, uses the DBMS metadata API as well, but it's free for you to use it as well. Now over to Rodrigo for some more extreme features.
Thank you, Daniel. This is water, by the way, at least this time. So now let's talk about DBMS Datapump usage. So we know very well impdp and expdp, which are the binaries we use to run the export and import with Datapump. However, those binaries, they translate the parameters that you provide into DBMS Datapump API calls. So what really is executed in the backend is the DBMS Datapump package in the database. This package, by the way, do further calls in another APIs, like the external table API, if you're using external table access method, DBMS metadata to get the metadata of the objects, and also direct path APIs. Those are just examples of some APIs that are used by the DBMS Datapump API. So we all use, again, DBMS Datapump through the expdp and impdp, okay? But you can do it straight away. You don't need to go through these binaries, and this is very recommended. So we have some tools that do that, like zero downtime migration, Enterprise Manager, SQL Developer, SQL CL, also ORDS, which is the Oracle REST Data Services. And you can also write your own tool, or you can write your own SQL block to do it. It's documented and supported, and we have it in Oracle official documentation. So here are just some ideas of things you could do with DBMS Datapump API. You could, for example, I see a lot of customers creating the export script in the OS layer with cron tab. So we have a cron tab job that we'll call expdp. However, you don't need to put it in OS layer. You can put it straight on the database. You can write, instead of a shell script, you can write a SQL block and call it, instead of using cron tab, using DBMS scheduler. It's much more simple. You don't need to store your password in text files or call Oracle Wallet. It's already inside the database, so it's much more simple in that sense. Also, you can put dynamically things on that, maybe based on the number of schemas, you maybe increase the number of parallels, for example, or get the schema names from a certain table inside your database. So there is a lot of logic you can put there. Also, for example, there is an article I wrote about 7 years ago about how to rename a schema using a loopback database link. This article, it's based on DBMS Data Pump API. So what I do simply is put a database link, point to the database itself, and then I call the DBMS Data Pump API to run an impdp using this database link, but I use the remap schema. So I change the name of the schema, meaning that I clone the schema. So that's a way for renaming the schema. Also, you could possibly take a snapshot of a given schema during application development, for example. So those are just some ideas. Now let's see how client calls are translated into DBMS data pump calls. So imagine here you have an expdp. Here is schemas equal to app. The first thing you would do if you are using DBMS data pump API is start with this open procedure. So the open procedure will instantiate a new job. And here H1 is a variable that will have the ID for this execution. It's a handler that will store a unique ID for this call. Now from this point, everything that we want to change in this export job, we are going to use this H1 variable. So for example, again, the schema is equal to app. So we need to add a filter here. So we use the metadata filter procedure and we specify that the schema that we are using is just the app schema. Also, we have a dump file. So you use the add file procedure. And here in file type, you'll see that we are adding a file type dump file, meaning we are adding a new dump file to this process. The same applies for the log file, but the file type here for the log file is file type log file. What about parallelism? You can use the set parallel procedure from the DBMS Data Pump API. So the set parallel here, we put degree equal to 4, the same value we put on the command line. But this is one of the advantages we have when we run this from inside the database. So here in this example, as you can see below, I'm getting the CPU count we have in the server and put in this variable. If you want to do this in the shell script, you would need to connect first on the database, get this variable, and put this in an OS variable and put this OS variable in the parallel call of your expdp binary call. So it's much more complex. Here I'm getting straight from the database that I'm already inside. And matrix equal to yes and log file equal to all, we can use the set parameter to define those variables as well. And finally, we start the job. So start job here, I'm passing the handler, and then this will put the job in background. I can optionally call this wait for job that's gonna wait for this job until it finishes and store in this job state variable if it was successful or if it failed. So now I can see what is the status of my job. Imagine now that you already have your script developed using the expdp command or the impdp command, and you want to convert it to a DBMS data pump call. You can rewrite it from scratch based on the slides that I just showed you, or you can use this event 146 to get what are the actual calls in DBMS Data Pump API when you run the command on the binary level. Remember that this system event is a bit resource consuming, so only try it on lab or test environments. So here first, what we do is we enable the SQL trace on this database. Then we finally call the expdp or impdp. After we run expdp or impdp, we will have in the trace file all the DBMS data pump commands that were called by the binary impdp in this example. So again, use DBMS data pump. It's a very good API. It's very well documented and everything is in the Oracle docs. We have very good examples there. Now it's with you, Bill.
Thanks, Rodrigo. Let's talk about restarting export and import jobs. Later in the webinar, we will show you how to stop and start a running job. Export can be restarted after the estimate phase of a job is completed. This is because the worker processes report job status by entering rows in the control table. The control table contains different types of rows, one of which is called the type completion row, as we see in this example. There is one completion row for each type of object that is exported. In this simplified example, we're showing table spaces and users. In this example, the export of the table space object type is complete, and the user type has started. The first user object that was exported set that time. Then, as we'll see in the next slide about restarting of an import, workers create object rows in the control table for each object of the user type. If all of the users were exported, the worker process would have updated the user completion row with a completion time. In this case, upon restart, a worker process detects that the users were in the process of being exported but didn't finish because there is no completion time. Data pump drops all of the rows that describe the users, drops the completion row, removes the XML stored in the dump files that describes the users, and then it configures the metadata API to start after tablespace, since tablespace is the last complete object type. It's worth noting that if a job is stopped intentionally using the command line interface, the stop command stops the job and allows it to be restarted. However, the kill command stops the job and removes the control table. Once the control table is removed, the job cannot be restarted. Imports can also be restarted using the control table. The tables scott.emp and scott.department were exported along with their indexes. After successful export, the processing_state column for each object row in the control table has the value R, designating retrieved or exported. And the value C in the processing_status column indicates that the objects are current or successfully exported. This is the starting point for an import. If an import job is started and then stopped, for instance after the table scott.emp is imported and before the table scott.department is imported, the rows look like this in the control table on the slide. The value W is the state field, indicates that the table scott.emp is written and imported, and the value C in the status field indicates that the objects are current or successfully imported. The value U, or unknown, in the status field for the table scott.department indicates that the import started but did not finish. When data pump import restarts, it looks for a row with the value U in the status field and continues with that object. In this case, the table scott.department will be imported again. After that table is created, the import job will continue with the remaining objects. In this case, it will be the two indexes that have an R for retrieved or exported in the state column. Now back to Roy for more on the interactive commands.
One of the little known features of Oracle Data Pump is the interactive command mode, which can give you a lot of control over a running data pump job. So let's take a look at it. The purpose of the interactive command mode is to be able to modify and query the status of a job so that you know exactly what's going on and can maybe change it in ways that would help performance or maybe compensate for other workloads on the system and do other things to the job that you might have forgotten to do in advance. So I'll give you an example of some of the commands that you can use. Now, it's important to recognize that some of these commands apply to both export and import, such as getting the status of a job, for example, or modifying the parallelism of the job while it's running. You can even change the tracing on a job and implement tracing if you decide that you need to diagnose some issues with it. But others may only be export or only on import. For example, the file size, the ability to change the dump file size that you are producing is, of course, only available on export because on import, the dump file size is already set. There are a wealth of commands that you can issue from the interactive command prompt to affect a running job, and you'll find those in the documentation. So now the next question is, how do you issue those commands, how do you access this interactive command mode? And there are two ways to do it. One is to simply hit Control-C during a running job. That will bring you to the interactive command prompt. You can issue commands and then tell the client to continue by issuing the continue client command. Another way to do it is to use the attach parameter on the data pump command line. You could have a data pump command running in one window and then in another window attached to that job and be able to monitor and affect that job using interactive commands. So I'll give you some examples of this in a very brief demo here. So let's just say that you start off and you've got a very simple export here. As you can see, it's a schema export, and we're just creating multiple dump files. But oops, we forgot to specify parallelism here. So this could impede our performance because we know we've got a lot of objects that we want to export here. So it started, and now we realize, oh, we forgot to specify parallelism. So we can break into the job with Control-C, and we can get the status of it. What that will show us is that there will be one and only one worker because our current parallelism for the job is just one. We didn't specify anything greater than that. We can then increase the parallelism for the job, and that will take effect immediately. When we continue the client, we will see the job progress, and then when we get to tables, we will be exporting multiple tables at a time. Now, another way to get to this would be to use the attach parameter using the job name. That is one of the very first lines in your data pump output is the name of the job. We can look at the status of it. And now we see that we have our current parallelism of the job is 4, and we have multiple workers spawned. Now, it's interesting that a couple of these workers seem to be idle at this point. And why is that? Well, look at the worker parallelism for worker 3. That's set to 3 right now. Worker 4 has a parallelism of 1. So what's going on here is that worker 3 has spawned 3 parallel query processes to do its work. Worker 4 is doing more work on its own. So you get now those 4 parallel processes, very similar to what I described earlier when I talked about export parallelism. So these interactive commands can really give you a look under the hood to see what's going on in the data pump engine, as it were, and allow you to control it, to manipulate it as a job is running. So I hope you find that useful. Now I'll hand you off to Mike for some troubleshooting tips.
Thanks, Roy. And this brings us right away to the last topic for today, troubleshooting. Of course, we don't want to talk about that, but sometimes it's really helpful, and it's actually key to help you progressing on your work. So in case of any issues, data pump not doing what you expect data pump to do, you open a service request. Now we would like to guide you which information you could check by yourself and which information is really helpful in case you open an SR. What should you upload? Let us start here with the first thing, the log files. And we talked about that before because it's really key if you open an SR that your data pump log files have been created with matrix yes and log time all. So you see here on the slide that the information is very different, and without the worker information and the exact timings, it's really, really hard to tell anybody and anywhere what has gone wrong or what has taken too long. So we need that, and you need that basically. But we told you before, that is really important. In addition, and I see often SRs where this has been simply forgotten, check by yourself your alert log and upload it with the SR. So here you see that the control process has written a message in the alert log. How do I see this is the control process? Because the DM00, D is for data pump and M is for the master. So this is the control process kicking in and starting with the job. I will repeat that later on. Here you see a standard generated job name. I highly recommend you that you define a job name by yourself, because when you troubleshoot, it makes your life really much, much easier when you have an individual job name for your data pump job to identify it in the queries, in the tracing, everywhere. Then, in addition, data pump workers and also the control process, they write trace files occasionally. So in the same directory where your alert log is, in the trace subdirectory under the directory, you find the trace files. Here again, in the top line, the brownish box, you see it has DM. This is the control processes trace file. And with that information, we find a lot of things already, what the job has been done, especially if something was slow, hanging, or taking too long, or doing strange things. Next thing is database views. Inside the database, we can see a lot about data pump already because it's using the API. And first of all, the most important view is DBA or CDB data pump jobs. There we can monitor the progress of a data pump job. And in this case, we have some really useful MOS nodes, very detailed with all the queries. So the output here from my job, I show you what it's doing, in which state it is right now, and how many sessions it created. That is just by using a query from that MOS node. And again, second time, the recommendation. If you want to troubleshoot data pump, if you want to dig deeper, it's almost key that you define a job name by yourself. So here my job name is my expdp1, and this makes it much easier to identify the data pump's job later on. DBA data pump sessions tells you then about the SQL statements a data pump session is executing right now. And this is extremely useful in case of a hang or a very slow operation. So when you have the feeling that data pump is not really progressing, what is it doing, then this can help you. And again, the MOS node is extremely helpful, giving you detailed queries to figure that out. And this brings me finally to $V session long ops. Most of you may know this view in the database already. Here we find out quickly how far data pump has been progressed. Because in the so far column, it tells us how many megabytes it has progressed. And this in relation to total work, the projected maximum megabytes data pump will work on. This gives you a very good information where data pump is right now and how far it will go at this point. This brings us then, if that hasn't helped and figured it out, to the final point, the tracing. Again, we have a very detailed MOS node here showing you all the trace options for data pump. And if you want to trace, your user needs to be a privileged data pump user, meaning it needs the exp full database or the imp full database role. And make also sure that your max dump file size is big enough, because when you start tracing, you get a lot of trace information, and these trace files tend to become very quickly very big. We have three options to trace. We can trace, first of all, with the trace parameter. So this would be in your par file, or if you're brave enough typing everything on a command line, then put it on the command line. Then the interactive mode, and as third option, put it into the SB file. And let me start here with the trace parameter. So we put it usually in our par file, and this allows tracing even of individual data pump components. So if you want to trace only the workers or only the control process or only the metadata API or whatever, it gives you full control. Still, normally you won't need that. You use that trace option 1FF0B00, and this gives usually enough information even for us in development. So normally we just go with this trace option. You can do full tracing with 3 Fs there, as you see in the slide. But in most cases, that is really not necessary to find out what has gone wrong. When you need more trace information, please revisit that MOS node. It gives you a lot more control and is very well documented there. It generates at minimum 2 trace files. One trace file is for the control process, having the M for master in it, and then at least 1 trace file for a worker. But for each of the workers, there will be 1 trace file. So at least 2 trace files will be generated in the trace directory. And these are the ones you need to upload then with your service request. Then you can trace also in interactive mode. If data pump is running now and you hit a slow situation, no worries, or maybe it's hanging at some point, then you type Control-C as we showed you before in the interactive mode. You are in interactive mode now. Now you attach to your process, to your job. And again, it's very helpful if you have defined a job name in this case, and then you use a trace option. Here we use a different option, but as I said before, the 1FF is the most liked one by us because it has the most important information in it. If it's really hanging right now and not progressing, you can start your job and use the skip current equals yes option, because that will skip the current action and then go on to the next one. That could be useful in such situations as well. And then you can put it also in your SP file or in Aura. So here the event for data pump triggering the trace is 39089. So you would put the event equals 39089 trace name context forever, colon, level, and then the bit mask for the trace event. Not used so often, but you could. Generally, when you deal with such problems, and I think we showed you that before, event 10,046 is really helpful. It's the first event when you start in Oracle support. I think this is the first thing you learn on day 3, how to use 10,046 SQL trace event, because it traces everything happening in a database. And you have certain levels, so you can go to level like 8 or 12 to have the binds and the waits. The waits will be really important here. Binds may not be so important. I use usually level 12, to be frank with you. And this gives me a lot of information. When you have that information, run it through tkprof, and then you get a readable output from that. That is really quickly done. And I think all that is described in this very useful Moss note about 10,046. With all that information put into an SR, hopefully you're happy ever after, and everything will be good. I think we are done for today. It's time to hand over to Roy for the final words for today. Thank you.
Well, thanks, Mike. As the sun sets, as it were, on our data pump webinar, I'd like to wrap up with just a little bit of information and thank you. First of all, we do have a dozen previous webinars on different topics that are all available on demand. You can get to them from the Upgrade blog. You see the URL right there on your screen, and it covers topics of anything from auto upgrade to our release and patching strategy to performance stability after the upgrade. Lots of valuable information there. Now, those webinars tend to run 90 minutes to 2 hours, and if you don't want to go searching for the information there, you could subscribe to our YouTube channel, where we break the webinars down into bite-sized chunks and issue new videos about a couple times a week on individual topics, anywhere from 30 seconds up to 5 minutes or so. So subscribe to that and you'll find a lot of useful information there, and it's pretty easy to search as well. The Upgrade blogs from Daniel and Rodrigo and of course Mike have a wealth of information on current topics, breaking news, technical articles, and so on. You'll never find a shred of marketing in our blogs or in our webinars. I hope you have noticed that as you've gone along viewing this one. Just a reminder on the video URL on the YouTube channel for those who might want that reminder. And then I'd like to point out that we have another webinar coming up in May, and that is what we call Auto Upgrade 2.0, because Auto Upgrade is constantly being enhanced with new functionality, whether it's around encryption with TDE, Data Guard, and other neat new features that you might want to take advantage of as you're upgrading to 19C or later releases. And finally, I would just like to thank you, our viewers, for attending, for spending the time to learn about upgrades and migrations. We hope you find it valuable, and thanks for watching.